Hello and welcome to your next S3 Computing Science lesson. In the last few lessons we've been looking at variables. Variables are like storage locations for values inside our computer programs. We've compared them to boxes with labels on the front to describe what contents they hold within. The labels are known as identifiers and the contents of the boxes are known as values or data. We've also looked at the fact there are two types of variable, number variable and string variable. String variables are pieces of data which hold any printable character which can be displayed on the screen, such as the letters of the alphabet, numbers, and symbols. We cannot do any maths on strings, but we can do something called concatenation, which means to join two or more strings together. This week we're going to be looking at creating generalized algorithms to solve problems and following something called the input process output model, and we'll be successful if we manage to implement user input using the ask and wait blocks in the Scratch programming language, and if we can implement output using the say block in the Scratch programming language as well. We're going to start off by looking at the world's worst calculator program. If you look in the Scratch example on the left hand side, you can see it's got 3 lines of code. In the first line, we set the variable first number to the value 20, the variable second number to the value 70. Then we have a third variable called total, which we set to first number plus second number. That means that total has the value of 70. This is the world's worst calculator because if someone were to use this calculator, it would only ever output the value 70, no matter what sum that the user wanted to do. In order to change the value of the sum, the user would have to go in and change our computer code. You wouldn't want any user to do this. Can you imagine if you had to change any of your appliances in the kitchen's code in order to change the timings, or if you were playing a computer game and in order to adjust your score you literally had to go in and change the code? You wouldn't enjoy that. So that's why this is the world's worst calculator and why we need to have user input and generalized algorithms. The programs that we're going to create from now on are going to follow this model of input, process, and output. Input means what information is being taken into the system or computer program. The process is what we do to the information we take in. How are we going to change or alter it to get the result that we want? And finally, we're going to output information back to our user. So what do we display on the screen after we've done our process? In order to create generalized algorithms, we're going to have to use user input in order to get values from our user without them having to change the code. In order to do this in the Scratch programming language, we use the ask and wait block. In the ask and wait block, you have a white box which allows you to type in a question to ask your user, which will appear as a speech bubble on the screen. Once this question has been asked, the user will then be presented with a text box where they can type their answer to the question. After they've hit enter or pressed the tick button on the text box, whatever they've typed will be stored in a special variable called answer, which is blue. And in our lessons, I'll probably be calling this blue answer. Blue answer can only hold one value at a time. So if you were to ask another question in your code, whatever was in blue answer before would be erased. We're now going to look at this in the Scratch programming language. In order to use user input in Scratch, we need to use the ask and wait block, which is found in the sensing panel. The ask and wait block has a default question of what's your name, but you can change this by double clicking in the white area and deleting the question. I'm going to replace this with, what is your favourite movie? But you can ask any question you would like in that box. The answer to the question is always stored within this blue answer variable. If we put the tick in the little question mark, the little checkbox rather, beside the answer variable, It'll appear up on our screen like any other variable. But we're going to grab this because we're going to use it later. So once I've asked them a question and run the program, it pops up with a little speech bubble saying what is your favourite movie, or whatever question we typed in here. And then this text bar appears at the bottom where we can type in the answer. So I'm going to write Star Wars. And then I can either click on the tick there, or I can press enter on my keyboard. You can see that the value Star Wars is then stored in the answer variable. So we can do whatever we like with this because we've got the answer pill, and that can slot into anything with rounded edges in our scratch block. I'm just going to grab a say block, which is our output block, and I'm going to stick answer in there. So if I run this again, what is your favourite movie? Star Wars. When I press enter, the cat should now say Star Wars. Obviously we could bring in other operators into this. If we were using numbers, we could use plus, minus, times. Because we're working with a string, I can use concatenation. So I can use the join block. I can stick answer in here. And then I can write is great. When I run this code now and type Star Wars, we should hopefully see the cat saying Star Wars is great. When we're working with the ask and wait block and the blue answer variable, I mentioned earlier that the answer is overwritten if we ask another question. So that means that the answer variable should not be a permanent home for any data that you want to store. Instead, we should create another variable to store the answer in so that we can use it later in the program. And we should give this variable a meaningful name that describes what value is being stored. So for example, in our previous code that I showed you on Scratch, we would maybe create a variable called favourite movie and store answer in that. So we're now going to look at how we might do that. So we're back in our code from earlier, which was our favourite movie program. So right now, the answer to the question is being stored in the blue answer variable, and that answer is of course the user's favourite movie. So instead of keeping it in the answer variable, we're going to store it in a variable called favourite movie, and then we can ask another question without losing the data that the user has already entered. I'm going to go ahead and go down to my variables menu and click make a variable. I'm going to call it favourite movie. Notice how I don't use any spaces and the second word is a capital. This is called camel case, and it's what you should use when naming your variables. You should always start with a small letter, but every second word and third word should start with a capital letter. So I've got my favourite movie variable now. After I've asked the question, what's your favourite movie, I'm going to insert the line, set your favourite movie to, and then I'm going to grab the blue answer pill from the sensing menu, so that whatever value is stored within answer after the question is asked is copied into favourite movie. And on line 3, the say block, I'm going to take out answer, and I'm going to put the variable pill for favourite movie in there instead. Just to prove that this works, I'm going to say that my favourite movie is Harry Potter now, even though that's a lie. And what we should see on the screen is, even though the variable says join favourite movie is great, it should still say Harry Potter is great. And that's because the answer might be inside blue answer, but it's also inside favourite movie. We didn't take it out of answer and put it in favourite movie, we copied it over. However, if I ask another question now, like what's your least favourite movie, we can see that the answer inside blue answer is going to change, but the answer inside favourite movie won't. So let's try that out now. So what is your favourite movie? Star Wars. And What is your least favourite movie? Well, I think that might be Forrest Gump. And you can see blue answer is now Forrest Gump, but favourite movie has remained Star Wars. So off the back of this, we could then improve our calculator program. We could ask the user to enter their first number and set the variable first number to the value stored within answer, and then ask the user to enter a second number and then store this as second number. We could then set our total to first number plus second number, and then we could say the value of total on the screen. So our two ask blocks and our set blocks for first and second number are our input. That's where we take information into the system. When we create the value for total, that's our process. We're taking the information we've taken in and doing something to it to create new information. Finally, when we use the say block, that is our output. We are displaying something to the screen. It's now time for you to complete a task. On Google Classroom, I've created a task sheet for task 3.1. You're going to have to identify the input, process and output for a given problem, and if you can, also figure out what variables you will need to use in this program. After that, you should create the Scratch program as detailed on the sheet, and then put it into the Class Studio for task 3.1 user input. Finally, there's a short piece on testing to complete and a challenge question at the end. If you have any problems, please let me know in Google Classroom. This week we've looked at breaking problems down into 3 chunks. Their input, what information are we taking into the system? Their process, what do we do to the information that we've taken in to create new information? And finally, output, what do we display at the end of our program? We have used the ask and wait block to store user input, and we've used the say block to output values. In our next lesson, we're going to look at using loops to repeat processes in our code.